Hey, welcome back. So, semester 2. Semester 2 is module 3, topic 1, proportions, okay? Double it in size, triple it in size, just like a road map, right? Every inch, 10 miles. You're good at that. You have those skills back from middle school. So, investigating proportionality. If we just click on the box, you're going to see all of these different units. And we're going to start out with what we know from middle school, making things bigger and smaller. So let's go. All right. Similar figures. Are we similar? And what's cool about your generation is you take a phone and you take a photo and you just make it bigger, make it smaller. And as you pinch it, everything stays in proportion. Let's see what kind of questions they ask. Okay, very first problem, we're going to be watching a little video here. Okay, let's see what they have to say.
Where you live, have you ever watched an eclipse where the moon passes in front of the sun? If so, you may remember that the circle of the moon almost perfectly matches the circle of the sun. This is because while the sun is about 400 times larger than the moon is about 400 times closer to us than the sun.
Proportions.
So the two circles match when they are lined up. That's how similar figures work in mathematics. Even though they are different sizes, two figures are similar if you can line them up and then zoom in or zoom out on one of them to make them match. When two figures are similar, they have two important features. All of their corresponding angle measures are the same. And you can multiply or divide all the side lengths of one figure by the same number to get the corresponding side lengths of the other figure.
Okay, so now that we remember the CPCTC, let's go to similar figures. Now remember when we did the angle, we couldn't say CPCTC, but the angles all stayed the same. So angle A corresponds to angle D. A, D, the measure 70. Okay, and BE 63. And CF would be 47. Cool. All right. Okay, I think we might be done with this one. Let's move on. Okay, let's watch another video.
Where you live, have you ever watched an eclipse where the moon passes in front of the sun? If so, you may remember that the circle of the moon almost perfectly matches the circle of the sun. This is because while the sun is about 400 times larger than the moon is about 400 times closer to us than the sun. So the two circles match when they are lined up. That's how similar figures work in mathematics. Even though they are different sizes, two figures are similar if you can line them up and then zoom in or zoom out on one of them to make them match. When two figures are similar, they have two important features. All of their corresponding angle measures are the same. And you can multiply or divide all the side lengths of one figure by the same number to get the corresponding side lengths of the other figure.
All right, so now we've got to do proportions. Okay? And On these, there's a little bit more math to do, okay? So let's bring our whiteboard in, okay? And let's focus on proportions, okay? So if we have this human, 6 feet tall, but when we redraw him, we shrink him in half. 6 becomes a 3, okay? We cut it in half. Then we can do the same thing if we're drawing a different figure. 6 becomes a 3. 12 becomes a what? The 12 becomes a what? Okay, so we write that out. 6 becomes a 3 as 12 becomes a half. What's half? 6. Okay, now if we were to do that mathematically, some of you might remember, some of you might not, but it's called cross multiply. Okay, 6 times the question mark is equal to 3 times the 12. Okay, and we have 6 in our variable is equal to 36. Undo the multiplication by divide, undo the multiplication by divide, and lo and behold, we get 6. All right, mathematically, let's look at a triangle. Okay, if we have a triangle, let's just use the famous 3, 4, 5 triangle. And then we redraw it and we multiply by 3. 3 times bigger. 3 becomes a 9, 4 becomes a 12, 5 becomes a times 3, 5 times 3, good, 15, okay? Well, mathematically, we can do that. 3 goes to 9 as the 5 goes to something, factors of 3. But mathematically, we want to be able to write that out, okay? So 3 times our unknown is equal to 9 times 5. So 3 times our unknown is equal to 45. Divide by 3, divide by 3, and lo and behold, 15 mathematically. All right, now in this problem, remember, we're not looking for volume, we're just looking for you to do the math, okay? So we have this triangle, okay? So I copied those 2 triangles, and we have 63, 70, 47. We know they match, okay? So let's do that. $70, 63, 47. Now we got to do the math. The key relationship was the 90 and the 36. 90 goes to 36. 90 goes to the 36 as question mark goes to the 38. As question mark goes to the 38. So I wrote those incorrectly, didn't I? Oops. Yes, I did. First mistake I made all day. Okay, so our key relationship, 90 to the 36 as question mark to the 38. Okay, so it actually says, how do we calculate the question mark? Okay, and in this case, we multiply both sides by the 38. Okay, so we're going to multiply both sides by the 38. We undo a division. Undo a division. Okay, so what do we get? 38 times 90 divided by 36. Okay, grab our calculator and just crank that out. Okay, so 38 times 90 divided by 36 is a 95. Okay, so 90 goes to the 36 as the 95 goes to the 38. So now we got to do the other guy. So what do we got? 90 to 36. And that goes to something to the 30. Okay. Multiply both sides by 30. Multiply both sides by 30. And lo and behold, 30 times the 90, all divided by the 36. And grab our calculator, 30 times 90 divided by 36. And we get 75. 75. So on this whiteboard here, we're going to need some scratch paper in order to do some of these problems. Okay, so we can visualize it. All right? So hopefully that was helpful. I'll see you in the next video so we can finish our first Mathia assignment of semester 2. Good to see ya. Oh, squares. We're good at squares. Boom, 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 boom. Yeah. Whoa, whoa. Wait a minute. If this is a square and this is a rectangle, how's that going to work? See you soon.